Okay, we're going to jump pretty far forward here and solve a rational expression that is a little bit tougher than the last one we did because we've got a couple more steps that we've got to do. So we're going to go ahead and jump right in here. So we're going to start by taking this bottom fraction here and we're going to try and factor this. So we have a 2x squared plus 15x plus 25. So this is not a monic trinomial, it's a general trinomial, so I need to factor using a different method. So I'm going to take 2 times 25 and I'm going to say, well, that's 50, so I'm going to use the mistake method here. And I'm going to say, what multiplies to 50 and adds a 15? So we have 1 and 50, obviously not, 2 and 25, and they've got to add. They're both positive here because they're multiplying and adding to a positive, so that's not going to work. 5 and 10, so 5 and 10 works here. Now this is the mistake method, so I have to say, oh, I forgot the 2, so I'm going to put that under, this should be a 10, sorry about that. There we go, okay. So I'm going to put that under both of my factors, and 5 over 2 does not simplify, so this factors to 2x plus 5, and 10 over 2 does simplify, so this is x plus 5. Okay, so what we have here now is our denominator is 2x plus 5, x plus 5. So I'll write this nice and neat for you guys. We have an x squared. I'm not going to rewrite the whole thing actually. So let's put this here. We have a 2x plus 5 and an x plus 5. Okay, so that is our new denominator. And our x squared minus 15, we can factor that because the 15 is not a perfect square. So we're left here. Now, I left a lot of room because we're going to have to find the common denominator. We have an x plus 5 once. We have a 2x plus 5 once. We have an x plus 5 once and a 2x plus 5 once. So our common denominator is x plus 5 times 2x plus 5. Remember, we take the smallest degree. So 1 degree, we only take it one time. So we're going to multiply each of these by x plus 5 and 2x plus 5. And we're going to clear, there we go. We're going to clear the denominators. So these just completely cancel out, and I bring down an x squared minus 15. Here the x plus 5s cancel out, and I bring down a 2 and a 2x plus 5. And here the 2x plus 5s cancel out, and I bring down an equals -3 and an x plus 5. So my denominators are completely cleared. So now I'm just going to go through and solve this problem. So I have x squared minus 15. This is going to give me a 4x and a plus 10. So we'll bring that down. And then here we have a -3x and a -15. And we're going to move everything over to one side and solve because we have an x squared, so we have a quadratic. So that's what we have to do for quadratics. So let's see here. Actually, before we do that, we need to combine this minus 15 and plus 10. So we have x squared minus 4x plus 4x minus 5 equals -3x minus 15. So we'll add a 3x here, and then we'll add a 15 here. And that's going to give us x squared plus 7x and plus 10 equals 0. So then we're going to take that and we're going to solve. And we can factor that, so no need for the quadratic formula. We have multiplies to 10, adds to 7, x plus 5, x plus 2. We take each of the factors and set them equal to 0, and we have x plus 5 equals 0. That's going to give us an x equals -5, and then we have x plus 2 equals 0, and that's going to give us an x equals -2. So we have our two solutions, and we may think we're done, but we're not completely done because we have to check in the original equation. So in the blue, we have here an x plus 5 and a 2x plus 5 for our denominators, and we say, will any of those denominators be 0 if I plug these in? So I say, well, if I plug -5 in, -5 plus 5 is 0. So I can't have that problem. That solution is what we call extraneous. So this solution does not work, but if I plug -2 in, I have no problems. So -2 would give me a 3 there, and a -2 would give me a 1 in that denominator. So I have no issues when I plug -2 in. Remember, it's only if it equals 0 in the denominator that we have to throw it out. So you have to make sure you remember to check that at the very end. My only solution for this one is -2.